All right, normally I start recording and I start the lesson, but right now we're going to start homework questions. Okay, so we need number 6, is that right here? Number 10, and then 10, and then 12, that's it. 6. Okay, R minus 12 equals 74 minus 7R to the 1/2. That is number 6, and then we'll do 10, and then we'll do 12. All right. Let's rewrite this so that it is in radical form rather than power form. Is that okay? Yeah. So nothing happens on the left. What happens on the right? This is 1/2, which means what's the radical? The index is 2. And then the power is 1. Any questions with that first step? Now, I was tutoring after school yesterday, and when I was helping the other teacher's students, I really wish they would have taught them the way I taught you, because it helps so much. What do we know about a square root? We know that this number right here has to be what? Positive, right? Or not negative. But we also know that this number has to be what? Also positive. So off to the side, let's talk about what possible x values could be our answer. Now what we did here will help us today with our lesson today. Yes. Okay, so looking out here, I know that 74 minus 7r has to be greater than or equal to 0. Is that okay? Now I prefer to keep the r on the left. It just makes more sense to me, even though it's negative. So let's get rid of the 74. So we have negative 7r is greater than or equal to negative 74. Then what? Now what happens when you divide by a negative? It flips. So r is less than or equal to 10.5-ish. Okay? Is that all right? Hold on. Or multiplying. Yes. Yeah. And it's only if what you're dividing by is negative. So since the 74 was negative, that doesn't matter. It's because of the 7. Okay, so this is the first part of our domain. Let's look at the next part. I also know that r minus 12 has to be greater than or equal to 0, right? So add the 12. R has to be greater than or equal to 12. If you keep talking, you're going to miss something. Yes? Yes. So I've got 2 different pieces of the domain, right? And I'm going to make this problem a lot easier. I like to look at the number line. Now whatever my answer is has to fit both of these criteria. Is that okay? Can my answer, this is 0, can my answer be less than negative, or less than 10.5, and also greater than 12? Can it be in both of those categories? No. Does that make sense? My answer can't be down here and up here at the same time, so because of that, there is no solution. You don't even have to solve the problem, because by checking the domain, my answer can't be less than 10.5 and greater than 12 at the same time. So when you have two domains, it has to fit in both. So your answer has to fit in both of those domains. Does that help? Yes. Okay, let's look at number 10. Freeze frame. And ready? Number 10. When I write this down, I'm going to write it inside of radical. That's your first step. And then, okay. Okay, the very first step is to do what? Isolate the radical. means we have to get rid of the minus 7. Let's do that. Now let's check the domain. Inside of here, this number has to be what?
Not negative.
Not negative, yes. Now if I were to solve that, that means 2x has to be greater than or equal to negative 3, right? Which means x has to be greater than or equal to negative 1.5. That's the domain. Do we have to look at the 7? Will this number ever be less than 0? No. So I don't even have to look at that part of the equation. You only have to look at this part if there's a variable out here. Is that okay? Now, I'm going to give a big fat if. If this was a negative 7 and that was just part of the problem, would you have to keep going? No. Because will you ever get a square root and have it be negative? If this was the problem, I would write no solution. Okay? Because I can't ever get a square root that's negative. No, we'll just erase it. Okay, now let's finish solving this. Once your radical is isolated, then what do? Yes, so how? Brandon, thanks for raising your hand. Good. Okay, hold on. So, now we have to square it, right? Yes. Square it. So this cancels with this, and you're left with 2x plus 3 equals 49. Good. Somebody knew. What's next? Brandon, you get a point. What's next? Okay, good. Point. 46, then what? Good. Good. If I call on you and I don't say point, assume you can get a point. Now don't be like Asher and like keep holding up your whiteboard and like, I just said point every time. It's the same problem. Point. Okay. So does that fit in my domain? Yes. So this is my solution. Raise your hand if you had that before you got here. Point. Last one. What? It's fun. That's part of my job. Number 12, yes. No. He's not the keeper of the point. I'm the keeper of the point. 12. All right. Number 12, what kind of radical is this? This is a fourth root raised to the third power. Now that is not how the original problem was written. Is there any questions with that first change? Questions? All right, the very first step is to get rid of that minus 3. So what do you do? Okay, so the fourth root of all of this stuff equals 8. Now, do we have to worry about the domain? It's a fourth root, so everything has to be what? Positive. So let's look at our domain first. Now, when I'm looking at the domain, I don't have to worry about the fourth. I don't have to worry about the third. I just care about this number. So x has to be greater than or equal to 2x. What am I doing? I don't know. I just heard something and I started writing. 2x plus 3 has to be greater than or equal to 0, which means 2x has to be greater than or equal to negative 3. That's your last one, Brandon. Oh, you were? We'll wait till you get column. No, then that's not counting against you. Okay, questions with the domain? All right, so let's go back to the problem. Now we have to cancel the fourth, right? So how do I cancel a fourth? 3 times no. Dominique. So you're gonna, it's hard to say the right math word. So yeah. So you raise it to the what power? Fourth power. Good. Dominique gets 2 points. Everybody else gets Ooh. What is it? Okay, good. So did I ever say you get 2 and then everybody else gets 1? Now what? A third root? Oh, good job. Nice catch. You can do that too. I'm just not. Yeah, Matthew. You take the cube root. If you do that, you get 1 point. Matthew gets 2. Cube root. Okay. So what happens is those cancel. You get 2x plus 3 equals what? And then you just solve it like normal, right? Yes, sir? Yeah, but then it's so ugly. Like you would have to do synthetic division and all sorts of garbage. So you could, you don't want to. Not better, but another. Yeah, another way to do it. Sure. But it confuses people, so we don't do it that way. You can't. And then I give you permission. Now we solve it like normal. We subtract the 3, so 2x equals 13. So x equals 6.5. Does that fit the domain we said at the beginning? Yes, so that is our solution. Okay. Good. All right, let's get out the notes. And we will correct that next time. Give you guys one more day. But next time we also will be correcting 6.6, so please have that ready. Almost there. Yes, Dominique. Yes. Here. We're going back. Everything today is a review. That's exciting. Everything you learned today, I taught you last year. If you were in my class, if you weren't in my class, I can't guarantee it happens. But it's the exact same stuff. Pretty much, yes. Now, okay, backtrack. This one is really good. Okay. A couple things about navigation to know. Yes. Fantastic. So if you were in Barker's class, you should know it. Anybody else? I'm pretty sure they're, let's go to the top. Whether or not you remember it is not up to me. Couple things of notation. This symbol right here. Not what I meant to do. This symbol right here. Hold on. I'm just talking now, so I'm not volunteering. You watching? Whiteboard should be put away. Put your phone away. I'm taking it. This symbol right here means you take the f function, you take the g function, and what do? Add them. Now, seriously. No. You take the f function, you take the g function, you add them together. That does not mean you take the f function, you take the g function, you add them together, and then multiply by x. That's not what that means. What that means is I have a function, and its variable is x. And I have a g function, its variable is x. I add those two functions together. Okay? I don't know. Because math people are lazy, and they like to make the shortest possible thing, that they can. And this looks a lot more cluttery than that. But it is confusing. What does this mean, actually, now that we're talking f of x? What does that mean? It's a function of x. That means I have some equation, and the variable I am using is x. Now, x is considered the input, right? It's the input variable. I'm putting a number into a function, and then I'm going to get some sort of output. The f of x is kind of like the y. It's the output. Okay? What does this mean? F minus g of x. That's 3. Okay, it doesn't matter. I didn't call on you. This means what? Asher. You take your f function, you take your g function, and you subtract them. If you knew that, you got a point. Everybody say thank you, Asher. Okay, this also works for multiply. It also works for divide. Now notice this in the divide section. You have that g of x does not equal 0, right? Because there are some times where part of your domain doesn't work. If I divide Then I have something in the denominator. A couple of units ago, it looks like this. And when we did something like this, was there an x value that did not work? We had an excluded value, we called it. X could not be what? -2. So on some of these problems, we are going to have domain restrictions. Okay? So on your homework tonight, I don't think it says it on every problem, but I want you to define the domain of every problem. Okay? Which is why what we did last time is going to be so helpful for today. And again, unless there is a denominator or a radical, you will not have domain restrictions. Okay? Denominator or a radical, we will not have domain restrictions. So let's look at this one. Let f of x equal x plus 7 and g of x equals the square root of x plus x. Yes? No, but we will get there in a minute. Notice I ignored the composition, the fog question. We will get there in just a moment. It's the hardest of everything. Okay? Yes. They're not too bad. You know a lot more now. Your brain has evolved. You're good. Yes, but you won't this year, I promise. Or you might. I can't promise, I guess. Okay, this means what? I take the f function, I take the g function, and I do what? Add them together. So my f function is 4x plus 7 plus the square root of x plus x. How do you finish that off? We're going to end this. We're not going to end it like x equals 5. This is going to be an expression. Yes. So point. Those two added together would be what? 5x. And then plus 7 plus the square root of x. That is my final answer. Now I can let you have some sort of variables that you can't use in this problem. There are some variables that you will be able to use in this problem. For example, what is the domain restriction if you have a radical? It can't be negative. So for my domain, I can jump and say x has to be greater than or equal to 0, because this is part of my function. This right here does not restrict the domain at all. There's no equal sign, I don't have to worry about that. But because there's a radical, I have to say everything inside the radical is greater than or equal to 0. That is my domain. We only worry about the stuff in the radical. Okay? Pretty much. Let's try number 2. Yeah. Brandon, please don't ask me again. Thank you. Now, be very careful when you're subtracting your g function. What do you have to do? Raise your hand if you know. Raise your hand if you know. When you're subtracting, what do you have to do, Carla? Yeah, we're going to distribute that negative. If you do that, you get 1 point. Carla gets 2. We distribute that negative. So when I rewrite it, I get 4x plus 7 minus the square root of x minus x. So your answer is going to look very similar with the exception of that 4x and the minus x. Combine those, what do we get? 3x plus 7 minus the square root of x. This is my function simplified. Now, is there a domain restriction on any of those numbers? Yes. The square root of x means the only x values I can plug into this and get a real answer is the number is bigger than 0 or equal to. Yes. We don't care about it. Because, for example, this is a big if. Just watch for a second. Please don't look down. If x was equal to 9, would I get a real solution? So 3 times 9, 27, plus 7 minus 3. I could simplify that and get a real number, right? But what if x was negative 9? If I try to simplify that, I would get negative 27 plus 7 plus 3i. Is that a real answer? No, that's a complex answer, which is why it doesn't fit in the domain. It fits here. That doesn't matter. It's here that's giving me the imaginary part. Does that make sense? how this part doesn't determine the domain? Okay, what about, I feel like you're okay with that. Can we skip 3? Yeah. Okay, let's look at number 4. You already did it. Fantastic. Look at number 4. This means what? Is this a composition question or is it the multiply question? Multiplication. That is the multiply. If you do that, you get a point. That is the multiply. Now I'm going to multiply that through. I have x squared minus 9 times x plus 3. Distribute. Plus 3x squared minus 9x. You didn't give me a chance to screw up. I wasn't there yet. This, any like terms to mind? No? This is my answer. Are there any denominators? Wait. Are there any denominators? No? Are there any radicals? No. So my domain on this question is all real numbers. There is nothing that x can't be. Nothing that x can't be. Yes. You could use synthetic division to factor it completely, but we're not going to make it smaller. Unless, if there was an equal sign, yes, we could make it smaller. But we're just trying to combine things. Okay, part number 5. Number 5, yes. So f over g. We take the f function. We take the g function. And we divide them. Is there a denominator? Yes. So on our denominator, to say the domain, we say all real numbers except. I'm going to let you have that shout out because you didn't say it super fast. That's 1. Okay, are you okay with that? Now that's not the simplified answer though. How do I simplify this? We're going back to Unit 4. Raise your hand if you remember. Going back to Unit 4. How do you simplify this? Oh, nobody's hands are in the air anymore. Put your hand down just a little bit if you've already gotten a double point today. You haven't? I feel so bad when somebody's hand's so high on the front row. Okay, go ahead, Brandon.
Basically, you simplify it to the terms that you multiply by, which is x plus 3 and x minus 3.
Okay, pause. Thank you. We have to factor the top. 2 points for Brandon, everybody else gets 1. Now, once I factor the top, are there things that can cancel? Yes. The x plus 3 cancels with the x plus 3, and what's my finalized expression? X minus 3, have a good lunch. Questions with that? That's okay, have a good lunch. I'm going to pause it. All right, let's keep going. Welcome back. I want you to look really quick at 4 and 5. Let's just get your brain back in the game for a second. Any questions with 4 or 5 before we move on? We're good?
Wait, I have one question.
Yes. Yes. Any other questions? Okay, moving on. Hold on. Remind me really quick what this means. Oh, you can't do it. Yeah. Point. Function using variable x. So, what does this mean? So what does that mean? Faith.
Oh, well, I don't know the math.
It's okay.
But you just times the
That's it. So this is saying what
And everybody who knew that gets a point. You get a point.
Did I call on you?
No, because you call it.
2. Who's the last person I called on, Brandon?
Yeah.
Okay. Shh, it doesn't matter. I didn't.
Negative point.
It's fine. I'm the keeper of the points. Okay, basically this means what is the output when x equals 2? Means if I have the function f of x and x is 2 or x is 3 or x is 8, what would the function be? If I want to find f of 3, I take my f function, and everywhere that there is an x, what do I do?
You plug it in.
Okay, so 3 times 3 minus 1. If you knew that, give yourself a point.
Yes.
Final answer is what? 8. Good.
Point.
Okay, try number 8. I did not just give you all a point.
Do you mean point?
No, well, only one. You didn't get a point for this one. You got a point for this one. Yeah, it's fine.
Question.
Yes.
Is this one I remember that. That was fun.
Okay, let's try another one. Number 8, g of 3. That means everywhere there is an x, what do we do?
Point.
You don't get to give points. No. I sort of want to give you guys fewer points because somebody thinks that they can give everybody else a point. That's not my eraser. Okay, moving on. What about number 7? Is it possible, pause, turn around. Is it possible to plug a function into another function?
Yes.
Yeah, so let's try that one. Looking at the f function, everywhere there is an x, what do you plug in? And then you simplify as far as you can. So it would be 9r minus 1. Yes. Of 3r? I would prefer it, yes. All right, next page. Okay, so now let's talk about the composition of functions. This is the fog question. I don't know why there's 2 ways to write it. This actually probably because math people are lazy. And they try to write things as short as possible. I prefer it this way. Raise your hand if you remember what either of these 2 things mean.
Oh.
You remember doing it before?
Oh, I know what it is.
If I've given you double points, I need you to lower your hands just a little bit so I don't call on you. I've given you double points for your hands.
I've never been given double points. I just tried to give them away.
Okay, Asher, what does that mean?
It means that you take the f of x equation thing, so like let's say down by the bracket, so it says 3x minus 2. You take that, and then for the x, you plug in g of x. So it would be 3 and parentheses x squared plus 1 plus parentheses minus 2.
Okay, so it's like you're taking one function and you're melting it into the other function, right?
you.
Okay, that's what the composition of functions means. Now, Asher gets 2, everybody else gets 1 that knew that.
Yeah. Thank you for
So, really quick, it doesn't tell us what the functions are. It tells us g of x equals this, f of x equals 3x minus 1. So you need to know that. So the term composition of functions or composite functions, it's kind of the same thing, refers to the combining of functions in a manner where the output from one is the input for the other. So you take one and you put it. Computer programmers use this idea all the time, where you take one mechanism that's working and the output of that will go into another one. It's how they use it, I don't know. I don't program, but I have a little. So those ideas are used a lot in the computer world. So for example, if g of x equals 4 and f of x equals 3x minus 1, what would f of g of x be? So this is just some massive substitution question. I'm going to take the g function and I'm plugging it into the f function. So this is what the composition looks like. If I substitute this with the function, it would look like that, right? And then everywhere on the f function that there is an x, what do I do? Plug in a 4, so it would be 11. So let's try this again, but I'm going to give you two different functions. What?
I'm doing the most, I automatically get points.
No, you do not, Brandon, or we stop the point system.
Oh, okay.
Thank you.
Thanks.
Pretend like you have those two functions. F of x equals x minus 1 and g of x equals x squared. What? No, but I'm good not to. Okay. Nope, don't
Oh my
do it
god.
I did that one with Katie, like, course,
Nice.
eggnog, you can run a lap, and then lose one, and then drink another, and then you run another lap, and you don't sit still up. My friend made it 8. He ran 8 cartons of eggnog and ran 8 laps before he finally threw
I bet
up.
he wasn't
Like,
dead
we were
after
just
that.
sitting there, like, it was amazing.
That's nasty.
I
I can
bet
drink like
he
3
felt
12
fancy.
I'm good to do that.
Then
Okay,
we
oh
had-
wait, pause. No more. Moving on. So f of x equals x minus 1, g of x equals x squared. So what does this mean? What function am I plugging into the other one? Yeah, I prefer to write it like this, so every time, so I don't confuse myself, I'll rewrite it. And then the g function is inside of the x function, right? So it's really easy, well, it's a lot easier to see the substitution. This is f of what? What is g of x? X squared. So now if I'm plugging that in, everywhere, so this is my f function, right? It's x minus 1. And everywhere there's an x, what do I plug in? Is there any questions with that? Now what's the domain of this function? The domain of that function, is there a square root?
Yes.
Is there a denominator? No, so the domain would be all real numbers.
Don't bring me something wrong.
Any questions with that? Okay, let's do the next one. What happens when I have g of f of x? So I take the g function and I'm plugging it into the f, nope, strike that, reverse it. I'm taking the f function and I plug it into the g function, right? What is f of x? Okay? So everywhere on the g function that there is an x, what do you do? X minus 1. How do you simplify this? Yeah, that is x minus 1 times x minus 1. And now what? Yep. X squared, and then you would have minus x minus x. Can I just do that at the same time? So it would be minus 2x, and then plus 1. That would be the f of g of x function. Yes? Huh? No, they're both x minus 1, so you'll get this. Lauren, did you have a question? I just questioned. What's the domain? Okay. Door. Oh no, I know what you're going to ask. I really don't want to.
You get a point.
I'm the only one with the prep.
Okay.
I'm sorry.
I've already covered for her once. I'm recording. Sorry, I love you. I just don't want to cover your class again.
Karma.
I just swore 3 times in my head.
I think I swore 4.
Don't think less of me.
I understand.
I have so much to do.
I'll be the sub.
I can
4,
be sub.
Yell at Marker, he's the other one.
5,
Do it.
6. No, I'm just swearing. That's all. 7. I don't know all the words, Asher. Okay. Can I bring them in here?
I don't care.
Okay.
I can teach.
Just take that down to 7. I almost said it out loud. And
Miss Thatcher.
and then I just flipped somebody off. It's all happening.
Miss Thatcher. You said it out loud. You didn't try to full recording. Hey.
Okay, moving on. We're almost done. Yes. Yes. It's okay. All right. So I feel like we're mostly. Are you okay with this?
Yeah.
There's one last thing I want to cover, and it's not on the notes. So let's look at the homework really quick. Because I feel like you guys, you're not the one that's making me cover somebody else's class.
That's called live.
Just whatever. Watch it.
You don't ever want to get tired.
I quit.
Don't quit.
Y'all are having a new teacher second semester because I just quit.
Number
9.
What happens?
Number 9.
Hey,
Really
say you
fun.
inspire the next Einstein.
That's me.
Well, then you gotta drop out.
Number 9. Okay, moving on. Brandon can't yell out. You're already at 3.
What? What?
Yeah. I know. Well, he's not at 3 yet. There was only 2 for him.
No, I don't have to. I only have one.
Now you do.
You're at 1.
Yeah, I know.
Number 9.
Now you do.
You're at 3 now.
We haven't done anything like this yet. Any ideas?
Yes.
Ideas. Raise your hand if you have an idea. And if it's a really good idea, I'll tell you you're right, but there's an easier way, and I'll see if we can get the easier way. Because there's 2 ways to do this. There's an easy way, and there's a slightly not easier way.
Wait.
Okay? What do you mean? Okay, so,
Is this like the FX anymore?
ooh, close. If it looks like this, then you would do H of G of 7. So, okay. Perfect. So this, you could do one of 3 things, or one of 2 things. You could either figure that out, and then plug in the negative 7. That's the harder of the 2 ways.
That's the harder one?
Or you could do, please listen, because you're more likely to make a mistake when you're dealing with variables. Or you could do H of negative 7. You could take G of negative 7, and what could you do between them? Subtract them. That's the faster way. So on your own, will you find H of negative 7 and G of negative 7 and then stop there? We'll do 9 and then we'll do 10 and then we're going to be done.
Seriously, you're not joking?
Well, the lesson's done and you can spend the rest, because I've got to copy some of these.
Wait, can I be in charge?
No, Brandon. I like you guys a lot, but my irritation level is very high right now. So do number 9, do number 10.
Okay. I'm trying to lighten your day.
It's not working.
I do
Do
that
number,
lighten?
you know, do my light, if you be quiet, do number 9 and do number 10.
Okay, that's fine.
See? Look, it's working already.
Wait.
No,
You
it's
have
fine.
another occupation set in that. Sure, we always do that now.
As a professional career, only a little bit of math. We're teaching that teaching right now.
Well, we love us. I mean, you can.
I'll have verses, no?
Of course you don't.
What's wrong with ours?
It's like when you
Yeah,
babysit
no
somebody else's
relationship
kids,
with that.
and it's just not good on you.
Well, I actually wanted to, so that's encouraging.
You're not done.
Well, it depends. I actually wanted
Number
to be,
9.
I wanted to be in math 10, 10,
Number
10,
9.
50, but I didn't like it. Give me number 3.
9.
Give me number 3.
9. You better be careful, because I'm about to email Mr. Miller and tell him I don't want any of you losing the class.
Oh,
Remember? How I said they're balancing the classes?
Uh-huh.
What I was just told today is I'll look for volunteers first.
Oh gosh.
Wait, do you have to like pick and get rid of people?
Possibly. So you better be quiet, do number 9.
Oh, my God. Wasn't me.
When you get like
I don't like them. I told, I promise, I'm going to try to keep you all here.
You need me to point this homework without me?
That's called compounding.
Okay. Number 9. What's H of negative 7?
14.
Negative 7 squared plus 5 times negative 7.
Okay. Negative 7 squared is 49. Minus 35 is what? 14? Okay, leave that for a minute. What is, let me pull this up a little bit, G of negative 7? So 4 times negative 7, right? Plus 2 is what? Now what do we do between these 2 numbers?
You subtract.
You subtract them, so you're going to say 14 what?
Plus.
Minus a negative 26. We know.
Yeah.
Which will change to a positive. If you skip steps, don't yell them out loud, because I can't skip steps. 40.
Do we not skip it so long?
No, because it's just a number.
So when it were to have like an X on that.
Yes. If any of your answers have X values, that's when I want you to do the domain. Josh, did you get this? Why the heck not?
Yeah, Josh.
That was censored. I'm so mad.
That was
I don't normally swear a lot. So if you just now feel less, if you think less of me now after you know I just swore 7 times and flipped somebody off in my head, I'm sorry.
I can flip someone off. In
Don't,
Chinese.
don't,
we're all human, it's okay.
don't do it. I'm just,
We all swear about
Did you say in Chinese?
my husband doesn't.
The pinky is a powerful
Okay.
thing.
One more. Number 10. Except I'm not going to do it if you guys aren't. And half of you are wanting to be with me. Another half is not.
Oh, I hate.
So this is h of g of 5, right?
Yeah.
So what am I going to find first?
You're going to H.
I'm going to find g of 5.
Yes, you are.
Okay? So g of 5 equals what?
16. I'm sorry.
Actually, 20.
Equals 24. Is that okay? Y'all need to stop talking to each other.
You said it's 5.
What?
You said it's 5. It's 4. Oh, I thought it was 4.
Is that okay? For those of you that are paying attention.
I thought you were doing
Okay.
Oops, my
Now what do I do with that 24? We take it, we substitute it in. So h of 24 is what? 4 times 24, which is 96, minus 4, should be 92. I believe that is everything for the rest of the day. I need to go print a review for somebody, but it is expected. You have 20 minutes left of class. You should be able to finish almost the entire thing. Yes, Caitlin. Thanks for watching. Peace out. Sorry, I swear.